Above us, every day, burns the very heart of our solar system, the sun. It is our constant, our giver of life, our cosmic lighthouse in an otherwise cold and endless night. For billions of years, it has risen and fallen across our skies, a quiet titan fusing hydrogen into helium at its core, bathing our planet in light and heat. But even stars must die. The sun, for all its brilliance, is not eternal. Its demise is certain, written in physics, modeled in equations, etched into the very fabric of time. And when it ends, the consequences will ripple across every world it has ever touched. This is the story of our sun's fiery demise, not a tale of myth or prophecy, but a science-driven journey through the final chapters of a star's life. A warning, a revelation, a look ahead, billions of years into a future none of us will see. To understand how the sun will die, we must first understand how it lived. Roughly 4.6 billion years ago, our sun formed from a vast cloud of gas and dust, a molecular cloud collapsing under gravity. At the center of this collapse, pressure and heat grew immense, until nuclear fusion ignited. A star was born. From that point forward, the sun entered a long, stable phase known as the main sequence, fusing hydrogen into helium in its core. This process, incredibly efficient, releases energy that balances the sun's own gravity, creating a stable equilibrium. And for nearly 5 billion years, it has remained in that delicate balance. But it won't last forever. Hydrogen, the sun's primary fuel, is finite. And as it is used up, the balance begins to shift. Currently, the sun is about halfway through its main sequence life. It has burned through roughly 50% of its hydrogen core, and it has about 4.5 to 5 billion years left before a dramatic transformation begins. As the hydrogen depletes, the core contracts under gravity. This contraction heats up the surrounding layers, causing them to expand outward. The outer envelope of the sun begins to inflate, slowly, then dramatically. The sun becomes a red giant. In this phase, the sun's radius will grow by over 100 times its current size. It will swell past the orbit of Mercury, then Venus, and possibly even engulf Earth. The skies will turn red. The oceans will boil. The atmosphere will be stripped. And the Earth, if it survives physically, will be rendered uninhabitable long before the final engulfing. Long before the sun becomes a red giant, Earth will begin to feel the consequences. In about 1 billion years, as the sun grows brighter and hotter, Earth's surface temperature will increase. Oceans will begin to evaporate, triggering a runaway greenhouse effect. The atmosphere will become thick with steam. Life, as we know it, will begin to collapse. By 2 billion years from now, surface water will be gone. The biosphere, what little of it may remain, will retreat underground or vanish entirely. Earth will become more like Venus, hot, dry, and lifeless. By 3 to 4 billion years, the sun's brightness will be 30 to 40% higher than today. Complex life will be impossible. Only microbes, if any, may survive in isolated refuges. Humanity, if it still exists, will have long since needed to escape to other planets, moons, or solar systems. The sun's death is not just an astronomical event. It is an existential deadline. Once hydrogen in the core is gone, fusion stops at the center and the core contracts further. But the outer layers, rich in hydrogen, ignite in shell burning, and the sun's outer layers expand even more dramatically. It becomes a true red giant, hundreds of times its original size. It will glow a dull crimson, its surface temperature dropping even as its volume skyrockets. The sun will lose mass through stellar winds, blowing off its outer layers in vast waves. This mass loss weakens its gravity, potentially sparing Earth from complete engulfment, though only as a burned-out husk. Inside, as temperatures in the core rise to over 100 million Kelvin, helium fusion begins, a sudden process called the helium flash. Helium fuses into carbon and oxygen, creating a new source of energy and briefly stabilizing the sun again, this time as a horizontal branch star. But it will not last. Once the helium is spent, the sun can no longer support fusion. It is not massive enough to fuse carbon or oxygen as larger stars do. So instead, its core, now an inert ball of carbon and oxygen, contracts once more, becoming incredibly dense. Around it, the outer layers drift away into space. What remains is a planetary nebula, a luminous, colorful shell of gas and dust, glowing from the heat of the core's ultraviolet light. It is not a planet, despite the name. It is the final breath of a dying star. These nebulae can last tens of thousands of years, spreading the sun's atoms across space. Earth's atoms, our atoms. We are, as Carl Sagan once said, made of star stuff. And in death, the sun gives that stuff back to the cosmos. At the center of the nebula, what remains is a white dwarf, a core no larger than Earth, yet half the mass of the sun, incredibly dense. Incredibly hot. It no longer fuses elements. It no longer shines by its own power. It glows from residual heat, slowly cooling over billions to trillions of years. A white dwarf is a cosmic ember, a final, silent monument to a once mighty star. Eventually, even this will fade, becoming a black dwarf, a hypothetical object that no longer emits light or heat. But the universe is not yet old enough for any black dwarfs to exist. That future is unimaginably far away. The sun's story will end in silence, cold and dark, its energy finally spent. Though the sun's death is inevitable, its legacy is already profound. It forged the conditions for life. It bathed our planet in light and warmth. Its gravity held the solar system together. And in its final act, it will scatter elements forged in its heart into the interstellar medium, seeding future stars, planets, and perhaps even life. The sun is not just a star. It is our star. And when it dies, it will carry with it the memory of every tree, every city, every poem, every dream ever lived under its gaze. It is humbling to know that everything we know, every atom in your body, was shaped by starlight, and that starlight, one day, will fade. But it is also beautiful. While the sun's death is billions of years away, it raises deep questions. Will humanity survive long enough to witness it? Will we have journeyed to other stars, built new homes around younger suns? Or will we vanish, one of many species swallowed by entropy and time? Some dream of stellar engineering, extending the sun's life, moving Earth outward, or harnessing its energy in Dyson structures. Others imagine terraforming Mars, colonizing Titan, or escaping the solar system entirely. The end of the sun is not just a deadline. It is a call to action, to explore, innovate, and understand. Because if life on Earth is to continue, it must one day leave the Earth. And in doing so, we carry the sun's light into the galaxy. The sun will not explode. It will not go supernova. It will not birth a black hole. But its death will be no less profound. It will bloat. It will burn. It will shed its skin and fade into the dark. It will light the sky one final time, and then leave behind only a glowing coal, dimming for eternity. Yet, even in death, it will shape the universe. The atoms it cast into the void may one day form new stars, new planets, maybe even new life.